This section will show you how to create your GitHub account. First, you need to open a web browser and go to github.com and fill in your account information. You will need to provide username, an email address, and a password. Now click the green Sign Up button. For the purposes of this course, the free account is sufficient, so go ahead and click Finish at the bottom. Now that we have created our account, we will need to confirm it. GitHub will send an email to the address you provided during the sign-up phase, so go ahead and check your email now. You will see an email from GitHub requesting your confirmation. Click on the link provided. This will open up a new tab to your GitHub account. Click the Confirm button towards the right. At this point, your account creation is complete. This section will show you how to get your repository in the Future Systems GitHub organization. This repository will be used for submitting your coursework and assignments and collaborating with your team members on your project. Now that your GitHub account is set up, you will need to form a group, and one person from the group will send an email requesting a GitHub repository. The email should follow this template. Address it to me, and carbon copy your team members. In this case, the example team members are Lovelace and emc2@gmail.com. Next, the subject line must read, Request Future Systems GitHub Project. Please use exactly the subject line, otherwise your email may get lost in the spam filters. The body of your email is as follows. On one line for each group member list, their name, comma, email address, space, and GitHub username. For instance, here's myself, my email, and the username I created. Since I'm working with Ada Lovelace and Albert Einstein, they each have a line with their information. Next, include the course number in a blank line. In this case, the course number is BUEX-V594. The rest of the email contains a summary of the project you are working on. For example, Ada, Albert, and myself may be working on a computer simulation of the theory of relativity. So we have the title and an overview of the project. Once this email is received and the repository is created, your group will have access to it. Please keep in mind that all members of your group will have write access to the repository. This means that anybody in your group can modify anybody else's work, even though Git will track these changes. Additionally, this repository is publicly available to the world to see, so please do not add any private information. We now need to provide GitHub with our SSH public key. Since the key pair has previously been generated, we just need to copy it. We will do so using the terminal. We open the terminal by, in the Finder, going to the menu bar and clicking Go, and then Utilities, then opening the terminal. Now we need to print out the contents of our public key. We do so by typing cat. Make sure that the key that you're printing out is the public key. It ends in .pub. Now we can copy everything from SSH RSA to the end of the comment. Now we open our browser and go to github.com. Go to your account configuration page and go to SSH keys on the left. We need to add the SSH key we just copied. Go ahead and paste it at the bottom. And let's copy the comment that we created the key with. This is the metadata. And paste it as the title. And now we can click Add. Now that we have configured GitHub for our use and you have been added to a project, you will need to configure Git to be able to work with GitHub properly. So first, log into your India account. You'll be using the terminal for this. You'll need to set your username and your email address to Git. with Git, and then optionally set an editor for it to use. I would recommend Nano. So we do this with the git config commands. Like so. We can look at the result of what we just did. At this point, you have your future systems and GitHub accounts, added your public key to GitHub, been given a project repository, and gone through the git config steps mentioned previously. Now we can go through the steps for using Git. First, open your browser to your project repository on GitHub. You will see a URL on the right. Click the SSH link, then copy the URL to your clipboard. Now we switch over to the terminal. We can clone the repository using the git clone command. You may need to enter your password to do so. Now let's go through the process of adding content to Git. First, we'll create a text file called fish.txt and write some lines to it. At this stage, the file exists, but Git is not tracking any changes made to it. If it were to be deleted, then it is gone for good, and we can inspect the status of Git using the git status command. There's a lot of information coming up on this, but the pertinent point is the untracked files heading, which lists all the files that Git sees that exist, but whose changes are not being tracked. There's also the helpful hint to use git add file, indicating a possible next step. Let us do so. In order to understand what git add does, we need to know the difference between each of the three states that content may be in. Content may be tracked, untracked, or staging. When the fish.txt file was created, the content was untracked. That is, any modifications to fish.txt would not be logged. If it is deleted, then it cannot be recovered. It cannot be shared using Git, and we cannot extract who made any changes, what those changes were, when those changes were made, or even why changes were made. By using git add, any content can be added into the staging area. Multiple files can be staged. Hypothetically, if other two files, hello.txt and world.txt, were to be created, they could be staged. Let's just do that real quick. By using the staging area, multiple files can be committed to Git as a single change, meaning a change is the addition, deletion, or modification of content in one or more files. At this point, we're going to undo the changes with the hello and world.txt. Let us now commit this fish.txt file. So we use the git commit command. The git commit command records everything in the staging area as a single change. When committing a change, it is necessary to add a message describing the change. The change itself stores the what content changed, and when, time and date of the change, but you must provide a message that describes the why of a change. This message is then stored with the change and can be viewed by looking at the history of the repository. We can see for ourselves that Git no longer sees any untracked content. We can use the git show command to view the contents of a previous commit. As you can see, there's a lot of information here. The pertinent points are who, the author name and email addresses provided, the what, you can see the exact change at the bottom, when the data commit was given, and why, the commit message that we provided. Additionally, you can see an overview containing the commit author, date, and message using the git log. In this case, we see the initial commit when I created the repository. Now we have the example counting fish. Recall earlier that we cloned this repository from some URL. We can take a look at that URL like so. This gives us several pieces of information. The first is this thing called origin. This origin is linked to this URL over here and is given the label fetch. This one, linked to the same URL, is linked to this push. This means that we can fetch any changes that are in the remote repository and make them visible locally. And we can also push any changes that are local to the remote repository. Here, the name origin is shorthand for this long URL. It is important to note that any changes we did via git commit are only committed to the local repository. They are not yet present at the remote. In order to share any commits that we have locally with the remote, we must push them. Let's do so. Let's break this down a bit. The first part is git push, meaning that we are telling Git to share our local changes with a remote repository. Now let us examine the origin and master parts of the command. Recall the output of git remote-v and git status after our commit earlier. The remote command provides us with the name associated with the remote repository, in this case origin. From git status, we get this thing called on the branch master. A repository can have multiple branches with different names, such as release-1.0, dev 1.3, and so forth. But this is beyond the scope of this lesson, but it suffices to say that all our commits so far have been to the default branch, which is called master. Let us look at the command again. Translated into English, this says, push the changes made to the current branch to the master branch of the repository called origin. In other words, git push updates the remote repository with all local changes. At this point, the remote repository reflects all changes made by myself. If someone else had made any changes or wanted to see these changes, they could execute a git pull. In my case, I'm trying to pull all changes that I've already made, and this just tells me that my local repository is up to date with the remote repository. So one feature of Git is that it allows multiple people to work on the same repository at the same time. So for instance, while I was writing about fish, Ada might have been interested in writing about eggs. So what I'm going to do is model the process of both Ada and I trying to make changes to the repository at the same time. So just to show you, this repository belongs to Ada. So, like me, Ada did a clone of the initial repository, and now is adding this eggs.txt. And like me, she will do a git add and then a git commit to mark these changes. Now, if she wants to push these changes to the remote, she will run into a problem. This push was rejected because both she and I made these changes at the same time, and the remote repository doesn't know how to resolve these. It needs a human intervention to be able to do things correctly. Since Ada is the one who's attempting to push, first what she'll do is pull the changes that I made and make them available locally. So what's happening here is that as we're pulling those changes, Git sees that I added a file and Ada added a file. And since the edits were done to separate files, the merge is very straightforward. So we can see here that the changes to fish are now visible in Ada's repository. You can see both eggs that Ada added and fish that I did. You can also look at the history. This is the very initial commit that both Ada and I have in common. This is the change that I made. And then this is the change that Ada made. And then this is the merging of those two changes. Now we should be able to push to the remote repository. At this point, you should be ready to use Git and GitHub for your assignments and your projects for this course. Please see the website for further exercises and other information. You can also find a lot more information on how to use Git and GitHub online. Also, you may contact myself and the other instructors if you require assistance. Thank you for your time.